Somewhere in the shoulder of Orion, a star is behaving in a way that should not be possible. It brightens without warning, it dims without explanation, it swells to a size that would swallow the orbit of Jupiter, and then, for reasons scientists spent over a century failing to understand, it goes dark, as if something inside it is dying in slow motion, one heartbeat at a time. For years, the official explanation was silence. Astronomers watched, they measured, they speculated, but nobody could explain why Betelgeuse, one of the largest and most famous stars in the night sky, kept flickering like a signal trying to break through static. Then, in the opening weeks of 2026, something changed. For over a century, Betelgeuse has done something no other naked-eye star does with such intensity. It pulses, it swells, it dims, and it brightens again, over and over, in a rhythm astronomers could never fully explain. It sits roughly 548 light-years from Earth, a red supergiant so enormous that if you dropped it into the center of our solar system in place of the Sun, its outer atmosphere would reach past the orbit of Mars, and possibly stretch toward Jupiter. It is a monster by any cosmic standard. And yet, monsters this size are not supposed to be unpredictable. Stars like this are supposed to follow physics. They are supposed to be understood. But Betelgeuse broke the rules, and in December 2019, it did something that terrified the scientific community and lit up headlines around the world. It dimmed nearly 40% of its normal brightness in a matter of weeks. This is not a subtle change. Imagine looking up at one of the brightest, most recognizable stars in the sky and watching it slowly fade before your eyes, as if a switch somewhere deep inside it was being turned off. What most people don't know is that this event, now called the Great Dimming, triggered a full-blown scientific panic. Was this the beginning of the end? Was the shoulder of the hunter about to detonate? Context. Here is where the story needs to slow down, because understanding what Betelgeuse actually is changes everything about what comes next. Betelgeuse is a red supergiant, a star in the final major stage of stellar evolution, the phase that comes right before a star either fades quietly or ends its life in one of the most violent events the universe can produce, a supernova. It has already burned through the hydrogen fuel that powered it for most of its life. Now, like an aging engine running on fumes, it is fusing heavier elements in its core, layer after layer, racing toward an ending that is, on a cosmic timescale, inevitable. But here is the detail almost nobody talks about. Inevitable in astrophysics does not mean soon. It could mean the star explodes tomorrow. It could mean it explodes in 10,000 years. Nobody, not even the world's leading astrophysicists with access to the most advanced instruments ever built, can pin down an exact date. This uncertainty is exactly what makes Betelgeuse one of the most closely monitored stars in the galaxy. Every flicker, every dim, every strange burst of energy gets studied like a warning sign, because if this star does go supernova, it will be visible from Earth in broad daylight, brighter than the full moon, for weeks. And that has never happened in recorded human history with a star this close. Escalation. So when the Great Dimming happened in 2019, scientists did not shrug it off. They scrambled. Telescopes across the globe turned toward Orion. Data poured in from ground-based observatories and from space-based instruments capable of seeing in wavelengths the human eye cannot detect. And what they found was almost more disturbing than a simple dimming. Researchers eventually determined that Betelgeuse had suffered what is now called a surface mass ejection, an eruption so massive that it blew off a visible chunk of the star's own surface, releasing an amount of stellar material roughly 400 billion times greater than a typical solar eruption from our own sun, 400 billion times. Sit with that number for a second, because it is almost impossible to comprehend. This wasn't a star having a bad day. This was a star tearing a piece of itself off and hurling it into space, where it cooled, formed a massive dust cloud, and blocked the star's light from reaching Earth. That is why Betelgeuse appeared to dim, not because it was collapsing, but because it had just done something so violent that the debris from the explosion cast a shadow over its own face. But here's where it gets worse. If a star can violently eject that much of its own material and survive, what does that tell us about the instability happening deep inside its core? And more importantly, what caused it? Deep breakdown. For years, that question had no clear answer. Some researchers proposed convective plumes, massive bubbles of hot plasma, over 1 million miles across, rising from deep within the star and disrupting the delicate convection cells that regulate its brightness cycle. That theory explained some of the behavior, but not all of it. Something still didn't fit. The pulsation cycle of Betelgeuse, the roughly 400-day rhythm scientists had tracked for over a century, kept showing irregularities that convection alone couldn't account for. It was as if something else, something external, was interfering with the star's natural rhythm. And this is where everything changes. In January 2026, a team of astronomers led by researchers at the Center for Astrophysics at Harvard and the Smithsonian announced a discovery that had been building quietly behind the scenes for nearly 8 years. Using observations gathered from the Hubble Space Telescope combined with ground-based observatories, they confirmed the existence of a companion star, a small stellar partner locked in an incredibly tight orbit around Betelgeuse. They gave it a name, Saguaro. And what they found about its orbit is the part that should genuinely unsettle you. Power shift. Saguaro is not simply orbiting Betelgeuse from a safe distance the way planets orbit the Sun. According to the research presented at the 247th meeting of the American Astronomical Society, this companion star's orbit brings it so close to Betelgeuse that it is physically passing through the supergiant's extended outer atmosphere. Think about what that means. This is not a star quietly circling another star from afar. This is a star clipping through the outer layers of one of the largest stellar bodies known to exist near Earth, generating a dense, swirling wake of gas as it moves, like a boat cutting through water. Except the water is the atmosphere of a dying giant hundreds of times larger than our Sun. The companion itself is tiny by comparison, described by scientists as a mere pinprick next to Betelgeuse's scale. But size doesn't matter here. What matters is proximity, and what matters even more is disruption. As Saguaro carves its way through Betelgeuse's outer layers, it is stirring up material, creating turbulence, and possibly influencing the very brightness variations that have puzzled scientists for generations. This is not chaos. This is a mechanism. For the first time, astronomers may have found a physical, structural explanation for why Betelgeuse behaves the way it does. Not random instability, but a small companion star quietly interfering with a giant, cycle after cycle, for who knows how long. Further escalation. Now here is where the real story gets uncomfortable, because a discovery like this doesn't just answer old questions, it opens up entirely new and far more dangerous ones. If a companion star has been orbiting this close to Betelgeuse, passing through its atmosphere repeatedly over time, what has that relationship done to the structural stability of the supergiant over the years? Could this ongoing gravitational and physical interference be accelerating processes deep within Betelgeuse's core? Processes that determine how close the star actually is to its final collapse? Nobody has a confirmed answer yet. What most people are not seeing is that this discovery doesn't calm the mystery of Betelgeuse, it deepens it. For years, the assumption was that Betelgeuse's instability came entirely from within, from its own internal fusion processes nearing their limits. Now scientists have to factor in an external variable, a companion star locked in a decaying, dangerously close orbit, one that some researchers believe may eventually spiral inward and be consumed entirely by Betelgeuse's expanding atmosphere. And if that happens, nobody knows exactly what the result would be. Could that kind of stellar merger event trigger a more dramatic destabilization? Could it accelerate a timeline that was already uncertain to begin with? These are not settled questions. They are the new frontier of the mystery. Consequences. Let's talk about what actually happens if Betelgeuse eventually goes supernova, because the scale of this event is almost impossible to overstate. When a red supergiant of this size reaches the end of its life, its core collapses in a fraction of a second, triggering a rebound explosion that blasts the outer layers of the star into space at incredible speed. The result is a supernova, one of the most energetic events in the known universe, capable of outshining an entire galaxy for a brief period of time. If Betelgeuse explodes, and it is close enough and aligned in a way that we can observe it clearly, astronomers estimate it could become bright enough to be visible in broad daylight, rivaling the brightness of the full moon for weeks or even months. For a species that has never witnessed a nearby supernova in recorded history, that would be an unprecedented cosmic event, a natural phenomenon lighting up both day and night skies, visible to anyone on Earth who simply looks up. And here's the part that should calm you down slightly, because it's important to say clearly, Earth is not in danger from this event. At roughly 548 light-years away, Betelgeuse is far too distant for a supernova to pose any physical threat to our planet, our atmosphere, or life on Earth. What we would get instead is a front-row seat to one of the rarest and most spectacular natural events imaginable, a real-time laboratory for understanding how supernovae forge the heavy elements that eventually become part of new planets, new solar systems, and yes, even new life. Future uncertainty. So where does that leave us? The truth is, despite everything modern astronomy has uncovered, the companion star, the surface mass ejection, the wake carved through Betelgeuse's atmosphere, the decades of pulsation data, nobody can tell you when this star will actually go supernova. Some researchers believe it could be tens of thousands of years away. Others argue that the increasing frequency of instability, combined with the newly discovered companion star's disruptive orbit, suggests the timeline might be far shorter than previously assumed. What most people are not seeing is that both of these possibilities can be true at the same time. Betelgeuse might continue this uneasy rhythm of dimming, brightening, and internal turmoil for another 10,000 years, all while a tiny companion star keeps carving its way through its outer atmosphere every single orbit. Or it might not. The uncomfortable reality of astrophysics is that some of the most important cosmic events in human history could happen without warning, on a night no different from any other, when a light in the shoulder of Orion suddenly begins to change in a way nobody predicted. Every observatory watching Betelgeuse right now, from ground-based telescopes to the most advanced space-based infrared instruments ever built, is essentially waiting, watching a giant breathe its final uncertain breaths, whether those breaths last another century or another 10 millennia. Final close. And that is the strange, humbling truth about Betelgeuse. We now know more about it than we ever have. We know it has a hidden companion. We know that companion is physically tearing through its atmosphere. We know the star violently ejected part of its own surface just a few years ago. And we know it is closer to the end of its life than almost any other visible star in our sky. And yet, for all of that knowledge, the most important question remains completely unanswered. When? Is the strange behavior we're seeing right now simply another cycle in a rhythm that has repeated for thousands of years? Or are we watching the opening act of something that has never been witnessed by human civilization? The death of a star close enough to light up our daytime sky? Nobody knows. Not the astronomers monitoring it in real time. Not the researchers who just discovered its hidden companion. Not the most powerful telescopes ever built by human hands. All we can do is keep watching that flickering red light in Orion's shoulder, knowing that somewhere behind that glow a countdown may already be running, one we cannot see, cannot hear, and cannot stop. The only certainty is this: whatever is happening inside Betelgeuse right now, we are witnessing it in real time, and we may be far closer to the final chapter of one of the sky's most legendary stars than anyone is willing to admit.